Example 2. Suppose that a family wants to fence in an area of their yard for a vegetable garden to keep out deer. One side is already fenced from the neighbor's property. That's this side here. So they're only going to have to buy fencing for this side, and this side. So if the family has enough money to buy 160 feet of fencing, what dimensions would produce the maximum area for the garden? Determine the maximum area for the garden. So in step 1, again, we're going to assign variables, and we already have them assigned up here in the illustration. So X is the width, and Y is the length of the garden. And if we write an equation that relates X and Y, using the information about the amount of fencing they will have, well, I'm going to buy X feet plus another X feet plus Y feet of fencing, and that is going to equal 160 feet because that's how much money I have to buy the fencing. So this will give me, if I simplify this equation, 2x plus y equals 160. Now what we want to do in step 2 is solve the equation we wrote in step 1 for y. So I'm going to subtract 2x from both sides, and that will leave me with 160 minus 2x. In step 3, we want to write a function in terms of x to represent the area of the garden. And if you remember the formula for the area of a rectangle, it's length times width. So our function is going to be f of x is equal to, well, the length of the garden is going to be y, and the width of the garden is going to be x. But if this is a function of simply x, we need to replace y with variables that include, or with an expression that includes the variable x, which we have up here. So what I'm going to do is take this expression and put it in place of y. So that's going to give me f of x is equal to x times 160 minus 2x. So now I have a function that is in fact in terms of x. So in step 4, now that you have a function in one variable, determine whether you are looking for where the function is equal to 0, which would be the intercepts, or the vertex of the function. So because we are asked to maximize the area, that is an indication that we are looking for the vertex. If we were looking for the intercepts, well, that is where this function would cross the x-axis. So that was where y would equal 0. But that is not the case for this example. So let's go ahead and put this function in standard form so that we can find a and b. So that would be 160x minus 2x squared. And if we put the terms in descending order, we would have negative 2x squared plus 160x. In this case now we can find that a is equal to negative 2 and b is equal to 160. And so we can use our formula, x is equal to negative b over 2a. So that would be negative 160 over 2 times negative 2. which would be negative 160 over negative 4, which is going to give me 40. So what that means is that the length, let's see, we let x be the width, I believe. Yeah, so x is the width. Sorry about that. So 40 feet is the width of this garden, and then the length is going to be, well, remember that y is equal to, we go back up here, 160 minus 2x, which is equal to 160 minus 2 times 40, which would be 160 minus 80, or 80 feet. So the length of the garden is going to be 80 foot, or 80 feet long. But that's not the only thing we were asked to find in this problem. So it said, first of all, what dimensions would produce the maximum area of the garden? Well, we found those dimensions to be 40 and 80. But it also asked us to determine the maximum area for the garden. So remember, this function is the maximum area, or the maximum area is going to be length times width. So f of 40 is equal to, remember we had x, let me write the function first. F of x is equal to x times 160 minus 2x. Well, x is 40. We just found 160 minus 2x up here, and that was 80. And 40 times 80 gives you 3,200. And in this case, since it's area, it would be square feet. So the dimensions are 40 by 80, and the maximum area is 3,200 square foot.